Good morning to all. Okay, in the last lecture we seen that what is the definition of inner product space and what are the four properties of inner product. Okay, and also some theorems that V be an inner product space, then alpha, beta, gamma belongs to V and C belongs to F, then the following statements are true. Okay, these are the five statements. Okay, so today we will see some more theorems. Scott's inequality. Okay, Scott's inequality and a minute, triangle inequality. Okay, before going to the theorem, let us see some notes. Okay, or remarks. Remarks on more. Okay, let suppose capital V is equal to F raised to N. Okay, Fn. And suppose a standard inner product defined on Fn. A standard inner product. Okay, defined on Fn. Okay, that is inner product of alpha and beta is equal to summation I running from 1 to n alpha I beta I bar, where this alpha and beta, these are the two elements of V. Okay, and when what is alpha? Alpha is equal to alpha 1 up to so on alpha n. What is beta? Beta 1 up to so on, this is beta n. Okay, this is the standard inner product defined on Fn. Then what is the norm of alpha? Then norm of alpha is equal to, okay, square root of inner product of alpha with alpha itself. Okay, so this is equal to square root of what is inner product of alpha with alpha? By this definition, summation I running from 1 to n alpha I into alpha I bar. Is it correct?
Yes, sir.
So that is norm of alpha is equal to square root of summation. We know that z into z bar is equal to what? Mod z square by using the this property of complex number. Okay, so here we get summation I running from 1 to n mod alpha I square. Okay, and this is what? The Euclidean definition of length. Okay, in 3 dimension, 4 dimension, 5 dimension, R2, R3, R4, we define the norm of a vector is equal to square root of summation of I running from 1 to n mod of alpha I square. Okay, Euclidean definition of length. Okay, for example, in R2, what is suppose alpha is equal to x1, x2. Okay, this alpha belongs to R2. Then what is the norm of alpha? Is equal to square root of
X1
x1
square plus X2 square.
square. Okay, here x1 and x2, these are the coordinates belongs to R. That's why x2 bar is equal to what? X2 here. Okay, तुमचं x2 बार म्हणजे काय येईल इथे x2. So this is x2 into x2 then x2 square here. Okay, summation x1 I running from 1 to 2 xi square. Okay, so in R2 norm of alpha is equal to square root of x1 square plus x2 square. In R3, suppose x belongs to alpha belongs to R3. Okay, that is alpha is equal to in the form of x1, x2, and x3. What is the Euclidean length? Norm of alpha is equal to square root of x1 square plus x2 square plus x3 square. Is it correct?
Yes, sir.
Okay. Any doubt?
No, sir.
one theorem is there. Look at this one. Small theorem is there. Let V, capital V, okay, be an inner product space. An inner product space, okay, over F, for the field F. Then for all alpha beta belongs to V, all alpha and beta, these are the two elements, belongs to V, and C belongs to capital F, the following statements are true. Following statements are true. Which one? First one. Norm of C into alpha is equal to mod of C into norm of alpha. Okay. Whenever this scalar comes out to this norm, then it is mod. Mod of C is into norm of alpha. Okay. And second one is norm of alpha is equal to 0 if and only if alpha is equal to 0. Okay, and in any case, whatever be the value of alpha, in any case of alpha, this norm of alpha is greater than or equal to 0. Okay, that is non-negative. This norm of alpha is non-negative. That is, the length of any vector belongs to this vector space, inner product space, is always non-negative. Okay, now look at that. Let capital V be an inner product space. Inner product space. Okay, that is IPS. Okay, now take let alpha belongs to V and small c belongs to capital F, okay, or capital C belongs to any scalar belongs to capital F, and we have to prove that norm of C into alpha is equal to mod of C into norm of alpha. Okay, first step we have to. Okay, we know that the definition of norm. By the definition of norm, that is length of vector on V, norm on V. What is norm on V? Norm of alpha is equal to positive square root of this one, inner product of alpha with alpha. Okay, so this implies what is norm of C into alpha? Okay, instead of alpha, here taken C into alpha. So put down here, instead of alpha is equal to C alpha. Positive square root of inner product of C alpha and C alpha. Is it correct?
Yes, sir.
So taking square on both sides, what do we get? This is C into alpha square. Okay, norm C alpha square is equal to inner product of C alpha with C alpha. Okay, so this implies norm of C into alpha bracket square, which is equal to, okay, this one, C into alpha with inner product of alpha with C alpha, okay, which is equal to C into, okay, by which property? Linearity property. Okay, now this is C bar into inner product of alpha with alpha. Which property? Linearity property in second variable. Is it correct?
Yes, sir.
Okay, which is equal to C into C bar mod C square. Okay, into inner product of alpha with alpha. Okay, right, left hand side C into alpha bracket square, norm square of C alpha. Okay, so this is equal to norm C alpha square. Okay, norm square C alpha is equal to mod of C square. Okay, and using this property, Z into Z bar is equal to mod Z square. What is this one? Norm of alpha square. Is it correct?
Yes, sir.
Okay, value of inner product of alpha with alpha is equal to norm of alpha square. So now taking square root of both sides, we get norm of C alpha is equal to mod of C, sorry, into norm of alpha. Okay, is the proof. First statement. Now the second one. What we have to show there? Norm of alpha is equal to 0 if and only if alpha is equal to 0. And any value of alpha for any case, norm of alpha is always greater than equal to 0. Okay, now look at it. Norm of alpha is equal to 0 if and only if. When this possible? If norm of alpha square is equal to 0. Okay, so this is if and only if. What is the value of this one? Inner product of alpha with alpha. Okay, is equal to 0. So when this possible? By the property of inner product space. Okay, inner product is non-negative property. Okay, so this happens only alpha is equal to 0. Okay, hence norm of alpha is equal to 0 if and only if alpha is equal to 0. Okay, and to prove that norm of alpha is non-negative. Okay, since norm of alpha is equal to what? Square root of inner product of alpha with alpha. Okay, so this implies norm of alpha square is equal to inner product of alpha with alpha. And this one is what? Greater than or equal to 0 by non-negative property of inner product. Is it correct?
Yes, sir.
Okay, so this implies norm square alpha is greater than or equal to 0. So this implies norm of alpha is greater than or equal to 0. Hence the proof. Okay, by taking square root on both sides, we get this one. Okay, any doubt? Okay, so here we prove that let V be an inner product space over the field F, then for all alpha beta belongs to V and the scalar C belongs to F. First one, norm of C alpha is equal to norm of alpha into mod C. Okay, and in any case, norm of alpha is always greater than or equal to 0. Okay, any doubt?
No, sir.
Okay, now the next theorem is next statement, Squarce inequality. Okay, okay, BSc ला झाला असेल हे कदाचित. Anyone knows what is Squarce inequality? फंक्शनल मध्ये झाला असेल कुठेतरी.
Norm of x into y is equals to norm of x into norm of y.
Norm of x. Norm of x into norm of y.
नहीं sir, norm of x into norm of xy.
No, तो नहीं है statement. Okay, Squarce. Look at it. In an inner product space. Okay, we prove that in any inner product space, mod of alpha beta, inner product of alpha beta, is less than or equal to norm of alpha into norm of beta, for all alpha and beta belongs to V. Okay, we know that. What is this function? This function is the V cross V to what? F na? Okay, inner products is the function from V cross V to F. So whatever be the value of this one, which one? Inner product of alpha beta. This value is scalar value. Okay, if this scalar value mod of this scalar value is less than or equal to norm of alpha into norm of beta. Okay, in any inner product space. And this is the Scott's inequality. Look at the proof now. Okay, there are two cases out there. If suppose alpha is equal to 0 and if alpha is not equal to 0. Okay. What happens if alpha is equal to 0? First case, if alpha is equal to 0, suppose. Then, now tell me, what is the norm of alpha?
0.
0. Okay. Also, what is the inner product of alpha beta? Value of alpha is 0. That means this is 0 in beta.
0.
Okay. Which is equal to again 0. Okay. And what is the mod of inner product of alpha beta? Mod of 0
Norm
is
of
equal
0.
to 0 again. Okay. And again, right hand side, norm of alpha into norm of beta is equal to what again?
0.
0. Okay, so therefore, look at here. Left hand side is what? Mod of inner product of alpha beta. This is 0. Okay, and what is the right hand side? This one, value of this one is 0. Okay, so this equation holds for this inequality holds for alpha is equal to 0. Is it correct?
Yes, sir.
Okay. So, therefore, in this case, the inequality holds. Which one? No, mod of inner product of alpha and beta is less than or equal to norm of alpha into norm of beta holds. Okay, so this is the case number 1. Now let us assume that alpha is not equal to 0. Okay, neat lakshya द्यायची. Let us assume that alpha is not equal to 0. Then what is the value of this one? Norm of alpha is not equal to 0. Okay, that is norm of alpha is what? Positive. That is length of that vector is positive. Okay, and also is positive real number. Is it correct?
Yes, sir.
Okay. Which one? 1 upon norm of alpha is what? Again, it's positive real number. Okay, if alpha, norm of alpha is positive, then 1 upon norm of alpha is again positive real number. Now, let us define one new vector belongs to inner product space V gamma such that, okay, so suppose this gamma, the nature of gamma, okay, using alpha and beta, the two vectors of V. Okay, using that two vector, we define one vector gamma. And what is the nature of gamma? Beta minus inner product of beta alpha divided by norm of alpha square into alpha. Okay, we know that inner product is the, what is the output of inner product is scalar value. Okay, or field one number. Okay, so this is the scalar one, constant one. Norm of this is alpha. Norm of alpha is what? Length of a vector.
Scalar.
Means this is again constant. So this whole quantity is what? Constant. So what is gamma? Gamma is equal to beta minus constant into alpha. Okay? Okay, हा दिसायला जरी वेगळा असेल तरी काय हा सगळा क्वांटिटी तुमचा काय कॉन्स्टंट. दिस इज द कॉन्स्टंट क्वांटिटी. So gamma is equal to beta minus alpha. Okay, beta minus constant into alpha. Okay, any doubt?
No, sir.
Okay, so nature of gamma is like this one. Okay, wait. Wait. So we define gamma is equal to beta minus inner product of beta alpha upon norm square alpha into alpha. Okay, now by the definition of inner product, we have what we have. Inner product of gamma and gamma is what? Always greater than or equal to 0. Okay, is it correct?
Yes, sir.
Now put the value of gamma here. This is beta minus inner product of beta alpha. Okay, divided by norm square alpha into alpha. Okay, with again what is gamma? Beta minus inner product of beta alpha divided by norm square alpha into alpha. This inner product is always greater than or equal to 0. Okay. Now using linearity property in inner product space. Okay, now look at here. This is the constant value. Okay, so this is beta. Second coordinate, this beta. This is the second coordinate. Beta minus inner product of beta alpha into alpha divided by norm square alpha. Okay, this is the first one minus. Now this one is what? Constant. Take this constant outside the inner product. So this is inner product of beta alpha divided by norm square of alpha. Okay, and in the second inner product space, alpha into inner product of alpha with beta minus inner product of beta alpha divided by norm square alpha into alpha. Is it correct? And this is greater than equal to 0. काय केलं कळाले का हे?
Yes, sir.
Okay, by using that theorem. कुठला theorem? Okay, this one. Okay, this one. Linearity property use केले काहीच नाही याच्यात. This one, this property. Okay, here the value of A and B is what? B ची value काय येणार तुमची? Inner product of beta alpha divided by norm square alpha. Okay, inner product of beta alpha divided by norm square alpha. This is the value of B. And what is A? A is 1. Okay. पहा नीट काय लिहिलं तुम्ही. Is it correct?
Yes, sir.
Okay. Now this is the using the linearity property. Okay. Now using the linearity property in second variable. What we get then? This is inner product of this beta as it is. Okay, याला वापरू यूज करूयात होती. Linearity property in second variable. Inner product of beta minus. Okay. This one is beta, inner product of beta alpha bar divided by norm alpha square. Okay, and into inner product of beta alpha. Is it correct?
Yes, sir.
For this one. Now this constant is as it is. Beta alpha divided by norm alpha square. Okay, now for this one, alpha and beta inner product of, okay, down minus प्लस ओके हा कॉन्स्टंट पूर्ण ह्याला मल्टिप्लाय. Okay, so again write down here beta alpha. Okay, this constant divided by norm alpha square. Okay, and this constant okay outside the inner product with bar. So what we get here? Inner product of beta alpha bar divided by norm of alpha square into inner product of alpha alpha. Okay, this alpha here, this alpha is here, and this quantity is what? Greater than or equal to 0. Okay, any doubt?
No, sir.
Now look at here. Wait a minute. Now this alpha, inner product of alpha with alpha is what? Norm of alpha square. So this value and this value get cancelled. Is it correct?
Yes, sir.
Yes.
Okay. Now this is plus beta alpha bar divided by norm square, norm of alpha square. Okay, काय सांगतो नीट पहा. बीटा अल्फा बार divided by norm square. Is it correct? The into m. Okay, so this quantity get cancelled with this one. Is it correct?
Yes, sir.
Okay, हा तर हा याच्यासोबत कॅन्सल झाला. This one cancelled with this one. Okay, inner product of alpha with norm of alpha square. Okay, and what is the remaining part? Beta alpha divided by norm square alpha with minus sign here, with plus sign, so this get cancelled. So what is remaining? Inner product of beta. So write down this inner product of beta is equal to norm of beta square. Okay, minus inner product of beta alpha, this quantity. Okay, into inner product of alpha beta. Instead of alpha beta, write down here beta alpha bar divided by norm alpha square. This value is greater than or equal to 0. Any doubt?
No, sir.
Okay, now we know that what we know, z into z bar is equal to mod z square. So this one, norm of beta square minus z into z bar is equal to mod z square. That means here norm of alpha beta, okay, or beta alpha काही द्या किंवा ह्याला काय करा, write down this alpha beta as it is, and this alpha beta bar करायला. Okay, any doubt now?
No, sir.
Okay, and this is now mod of alpha beta divided by norm of alpha square, which is greater than or equal to 0. So this implies norm beta square is greater than or equal to mod of inner product of alpha beta divided by norm of alpha square. This implies norm of beta square or norm square beta into norm square alpha is greater than or equal to mod of inner product of alpha and beta. Okay, square illa?
Yes, sir.
कोण सांगा? Okay, now taking square root on both sides. Okay, so this implies norm of, mod of inner product of alpha beta is less than or equal to norm of alpha into norm of beta. Hence the proof. Okay, any doubt up to here? खूप सोपं चॅप्टर आहे, काहीच नाहीये, फक्त मेकॅनिकल पार्ट आहे. फक्त तुम्हाला एकानंतर एक स्टेप सॉल्व्ह करायची आहे. डोक्याचा भाग काहीच नाहीये. ओके, एकदा हे कन्सिडर केला की linearity property in first variable, linearity property in second variable use. Okay, then we get the required result. That is mod of inner product of alpha beta is less than or equal to norm of alpha into norm of beta. ओके, फर्स्ट चॅप्टर सारखं नाही आहे तुम्हाला काय डोकं लावायचं, फक्त मेकॅनिकल पार्ट असल्यामुळे इतकं काय अवघड नाही आहे. ओके, सो दिस इज दी स्कॉट्स इनइक्वालिटी. एनी डाउट?
No, sir.
Okay, now the next inequality is triangle inequality. Okay, now tell me when this inequality becomes equality. हा inequality कधी equality होईल? Equal कधी होतील? When this inequality becomes an equality. If alpha and beta are dependent on each other, then this inequality becomes equality. Okay, कधी होतील? जेव्हा अल्फा आणि बीटा हे डिपेंडेंट असतील. डिपेंडेंट म्हणजेच काय? वन इज स्केलर मल्टिपल ऑफ अदर. ओके, हे पाहून उपयोग नाहीये नुसतं थेरम, हे सॉल्व्ह करावं लागेल तुम्हाला. कधी एक्झाम्पल घेऊन चेक करावं लागेल. टेक अल्फा इज इक्वल टू x1 x2. ओके, बीटा इन R2 मध्ये घ्या. ओके, y1 y2. ओके, चेक करा. नॉर्म ऑफ अल्फा काढा, नॉर्म ऑफ बीटा काढा, दोघांचा प्रोडक्ट घ्या. करूयात का? थांबा, करूनच दाखवूयात. ओके, सपोज दिस अल्फा इज इक्वल टू 1 2, बीटा इज इक्वल टू 2 3. Okay, what is norm of alpha? Length of this vector from origin.
Square root of 5.
Square root of 5. Norm of beta.
Square root of 13.
Square root of 13. What is the product of these two one? Norm of alpha into norm of beta is equal to square root of 5 into square root of 13, which is equal to square root of 13 into 5. Okay. What is the inner product of alpha beta in R2? कसा डिफाइन केला आहे आम्ही? I running from 1 to 2 xi yi bar. Is it correct? असा डिफाइन आहे. Okay, standard. So this is 1. This is it. This is equal to समय काय येईल इथे? x1 y1 plus x2 y2. Okay, y bar का नाही घेतला? बिकॉज हा R2 मधला एलिमेंट आहे. ओके, सो त्यामुळे बार घेतला तरी चालेल, नाही घेतला तरी चालेल. So x1 y1, so y1 is 2, x2 y2 is 6. What is x2 y2? This is 1, this one is 8. Okay, so what is mod of alpha beta? Inner product of alpha beta is mod of 8 is equal to 8. Okay, whether this 8 is less than or equal to this one?
Yes, sir.
Okay, स्क्वेअर करा दोन्हीचं, काय होईल? 64. 13 into 5 आहे का?
Yes, sir.
64 is less than or equal to 65. Is it correct?
Yes, sir.
तो चेक करायचं असं कुठलाही घेऊन लगेच. एक्झाम्पल घेतल्यानंतर कळेल, व्यवस्थित कळतं मग अजून. ओके, सो दिस इज कॉल्ड एज स्कॉट्स इनइक्वालिटी. Okay, now next one is triangle inequality. Any doubt in this theorem?
No, sir.
No, sir.
थेरम शिकून उपयोग नाही बरं का, तो अप्लाय करता यायला पाहिजे. अप्लाय केल्यानंतरच कळेल. ओके, नाउ टेल मी व्हॉट इज द इनर प्रोडक्ट ऑन सेट ऑफ ऑल द मॅट्रिसेस ऑफ n क्रॉस n. पाहिलं का हे कसं डिफाइन केलेलं आहे? स्टँडर्ड इनर प्रोडक्ट ऑन V, where V is set of all n cross n matrices where all the entries belongs to R. पाहिलं का हे कसं होतं डिफाइन? नाही, पाहते, चेक करा. ओके, प्रत्येक गोष्ट मी सांगितल्यानंतर किंमत नाही राहणार पाहिजे. ट्रायंगल इनइक्वालिटी. Anyone knows what is triangle inequality?
Norm of x plus y is less equal by norm of x plus norm of y.
Norm of alpha plus beta is less than or equal to norm of alpha plus norm of beta. Okay, in an inner product space, prove that. Okay, norm of alpha plus beta is less than or equal to norm of alpha plus norm of beta. Okay, now look at the answer. Let this V be an inner product space. Inner product space. And alpha and beta are the any two vectors belongs to V. Okay, आणि हे पण चेक करा की ते जर वन इज इंडिपेंडेंट इन अदर असेल तर हा इक्वल येतो. ओके, वन इज स्केलर मल्टिपल ऑफ अदर. जर अल्फा इज इक्वल टू 1 2 असेल आणि बीटा इज इक्वल टू 2 4 असेल तर पहा दोन्ही इक्वल येतात की नाही, चेक करा त्यानंतर. ओके, इफ व्ही इज इक्वल टू आहेत का, हे डिपेंडेंट आहेत का अल्फा अँड बीटा?
Yes, sir.
Yes, sir.
ते तरी कळतं ना.
Yes.
ओके, लेट व्ही, वेट चेक करूयात कोणाला पाहिजे, कोण आहेत अजून बाकीचे. ढगे यामध्ये आहेत का, ऐकतायत काय?
हो सर.
हा, सांगा हे अल्फा अँड बीटा वेदर these two vectors are dependent.
Yes, sir.
How? What is the relation between alpha and beta?
Scalar multiple.
What is that scalar?
अल्फाची व्हॅल्यू बीटाच्या स्केलर मल्टिपल मध्ये आहे ना.
ते स्केलर मल्टिपलची व्हॅल्यू काय मग त्या? सिमरन शेख left the meeting. Okay. Beta is equal to 2 times alpha. बोला. Okay, let V be an inner product space and alpha and beta are the two vectors belongs to V. Then we have to prove that norm of alpha plus beta is less than or equal to norm of alpha plus norm of beta. Okay, we know that. What we know? Norm of alpha plus beta. What is the definition of norm? Which is equal to square root of inner product of alpha plus beta with alpha plus beta. Is it correct?
Yes, sir.
By definition. So squaring on both sides, what we get? Norm square of alpha plus beta is equal to inner product of alpha plus beta with alpha plus beta. Okay, now using the linearity property, this one left hand side, norm square of alpha plus beta is equal to this one is alpha and alpha plus beta plus inner product with beta with alpha plus beta. Okay, is it correct?
Yes, sir.
So this is equal to inner product of alpha with alpha plus alpha with beta plus beta with alpha plus beta with beta. Is it correct? Alpha,
Yes, sir.
alpha आणि हा alpha आला इथे. Okay. Okay. Any doubt?
No, sir.
Wait a minute. Okay, so this one is inner product is alpha alpha, alpha beta, beta alpha, and beta beta. Is it correct? Any doubt?
No, sir.
Okay, कसा आला कळालं का हा linearity property in second variable. Okay, what is that second scalar is 1 and 1 bar is 1. Okay, so this is norm square of alpha plus beta. Okay, this is equal to norm square of alpha plus beta square is equal to what is the value of this one? Norm of alpha square. Okay, and this one is inner product of alpha beta plus inner product of alpha beta bar plus inner product of norm of beta square. Okay, okay, any doubt?
No, sir.
No, sir.
Look at here, z plus z bar is equal to 2 times of real part of z. कळते का काय सांगितलं मी? Suppose z is equal to x plus iy. What is z bar? X minus iy. What is z plus z bar? 2x. Okay, which is equal to 2 times. What is real part of z? Okay, hello.
Yes, sir.
Yes, sir.
Reply द्या काहीतरी. So this one is norm square of alpha plus beta is equal to norm square of alpha plus, write down this one. This one, okay, this is in the bracket. Norm square of beta. Okay, z plus z bar is equal to 2 times of real part of x. 2 times of real part of z. Here, this is z. This is z bar. Okay, alpha beta. ओके, मला हा स्केलर माहित नाही आहे रियल आहे की कॉम्प्लेक्स आहे, त्यामुळे मी असं लिहिलं. ओके, एनी डाऊट?
No, sir.
Okay, now look at here. One more property is there. Real part of z is always less than or equal to mod z. कसं काय? Suppose z is equal to x plus iy. What is the real part of z? X. What is mod z? Square root of x square plus y square. Okay, म्हणजेच काय, हा x always less than or equal to mod z, that is x square plus y square. If y is equal to 0, suppose, okay, imaginary part is 0 in the complex number, then what we get, this is x is less than, this is x square, that is x is less than or equal to x. Okay, whether this condition holds? Yes. म्हणजे या x मध्ये काहीतरी ऍड केलोय आपण, then x is always less than or equal to, हा ग्रेटर कधीच होणार नाही. Is it correct? हा ग्रेटर कधीच नाही होणार. Okay, any doubt?
No, sir.
No, sir.
पहा पुन्हा पुन्हा सांगू देत का? This is the norm square of alpha plus beta is equal to norm square of alpha plus norm square of beta plus 2 times of real part of inner product of alpha beta. I don't know whether this inner product is real or complex. Okay, now what we know, that this real part of z is always less than or equal to mod z. Why? Suppose z is equal to x plus iy is the complex number. Okay, what is real part of z?
X.
X. What is mod z?
X square plus y square. Square root.
Square root of x square plus y square. ओके, म्हणजेच या ह्याच्यामध्ये y मी जरी 0 जरी घेतला हा y, ओके, इमॅजिनरी पार्ट मी सगळ्यात कमी किती घेऊ शकतो? 0. ओके, इफ सपोज y is equal to 0, so what happens? Mod z is equal to x. Okay, so here real part of z is equal to mod z if y is equal to 0. ओके, आता y पॉझिटिव्ह असू दे निगेटिव्ह असू दे, y स्क्वेअर ऑलवेज काय असणार पॉझिटिव्ह. ओके, इज इट करेक्ट? y स्क्वेअर ऑलवेज
Yes, sir.
सो या नंबर मध्ये मी काहीतरी पॉझिटिव्ह नंबर ऍड करतोय, याचाच अर्थ काय, हा ऑलवेज लेस दॅन ऑर इक्वल टू असेल. इज इट करेक्ट?
Yes, sir.
Yes, sir.
बीएससी ची प्रॉपर्टी आहे. ओके, बीएससी ला व्हायला पाहिजे. कॉम्प्लेक्स अनालिसिस पेपर आहे ना बीएससी ला?
Yes, sir.
होता sir.
तर माहिती पाहिजे. ओके, राईट. Okay, so using this property, this one is norm square of alpha plus beta square. Okay, so instead of here equal to sign, this is less equal now. Okay, norm square of alpha plus norm square of beta plus this two is as it is. Now real part of this one z is less than or equal to mod z, and this is less than or equal to. Okay, ही क्वांटिटी असेल तर इक्वल क्वांटिटी येणार. दिस इज इक्वलिटी साइन. ह्याच्यापेक्षा मोठी क्वांटिटी आपण काय करतोय, ह्याच्यात लिहितोय, या इक्वेशन मध्ये पुट अप करतोय, म्हणजे हे इक्वेशन काय होईल, लेस दॅन ऑर इक्वल टू. इज इट करेक्ट?
Yes, sir.
काय म्हणतोय पुन्हा लक्ष द्या, काही जणांना नाही कळणार. हियर द इक्वल साइन इज देयर, हियर लेस दॅन ऑर इक्वल टू. वाय? बिकॉज वी रिटर्न हियर the value of this one, real part of inner product of alpha beta, it's always less than mod z. Okay, by this one. म्हणजे ह्याच्यापेक्षा मोठी क्वांटिटी आपण काहीतरी लिहितो. जर इथे 5 असेल तर आपण 5 किंवा 6 लिहितोय. 5 पेक्षा मोठी क्वांटिटी आपण ऍड लिहितोय ह्याच्यात. ओके, तर मी 6 लिहिणार. सो दॅट्स वाय हियर दी काय येणार आहे, the plus 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 6. This is less than or equal to. Now this equality becomes now inequality. Is it correct?
Yes, sir.
Okay. Less equal sign. So here norm square of alpha plus beta is less than or equal to norm square alpha plus norm square beta plus 2 times of real part of not z here. Okay, what is z here? Inner product of alpha beta. Okay, by Scott's inequality, alpha, this is norm square of alpha plus beta is less than or equal to alpha square. Okay, this is 2 as it is. What is the value of this one? By about theorem, mod मध्ये येणार ना तुमचा mod z, that is mod z तुमचा, and this one is there. Okay, mod of inner product of alpha beta. Okay, by this Scott's inequality we have 2 times of norm alpha into norm beta. The value of this one, okay, is less than or equal to. ह्याच्यापेक्षा मोठी क्वांटिटी कोण आहे, नॉर्म ऑफ अल्फा इंटू नॉर्म ऑफ बीटा. ओके, म्हणजे या इक्वेशन मध्ये या इक्वलिटीवर काहीच हे होणार नाही, परिणाम होणार. ओके, इफेक्ट नाही होणार. इज इट करेक्ट? प्लस this
Yes, sir.
norm square as it is. Okay, any doubt now?
No, sir.
No, sir.
Okay, ह्याच्याबद्दल ही क्वांटिटी कशा लिखायला, in place of mod of inner product of alpha beta we return by Scott's inequality, the bigger quantity than this one, so no effect on this sign. Okay, so now this is equal to this implies norm square of alpha plus beta is less than or equal to norm of alpha plus norm of beta bracket square. Is it correct?
Yes, sir.
Bracket square.
Yes, sir.
Now, taking square root on both sides, we get norm of alpha plus beta is less than or equal to norm of alpha plus norm of beta is the group. Okay. So what is the note? The Scott's inequality. Scott's by. Okay, Scott's inequality becomes equality. Inequality converted into equality if and only if alpha and beta are dependent. Is it correct?
Yes, sir.
Okay. Any doubt up to here? काही डाऊट असतील तर विचारू शकता. Okay, now the next definition is orthogonal vector, orthonormal vector. What is the orthogonal set? What is orthonormal set? Okay, when we say that they are orthogonal, two vectors are orthogonal when the dot product of two vectors are zero na.
Yes, sir.
Yes, sir.
इथे डॉट प्रोडक्ट नाही म्हणायचं इन जनरल. ओके, आता टू मध्ये डॉट प्रोडक्ट झाला. in general form we use inner product. Okay, inner product of alpha beta is equal to 0, then alpha is orthogonal to beta or beta is orthogonal to alpha. What is the meaning of orthogonal? That is alpha is perpendicular to beta. Okay, so this part we will see in the next lecture. For today it is sufficient. Any doubt up to here?